everyone, in this video we're going to looking at, given you already obtained our binary outcomes using the logistic regression, how do you know your model doing a good job so that you feel good about use the model to do the prediction? So first of all, I want to emphasize that the R square we did before no longer works. I know in the data science field we call R square but the R square, the way they calculate are different from what we just saw in the linear regression model. Okay, so for the binary choices model, how do we know our model doing a great job to predicting the outcomes, right? So as you can see, all the outcome predicted out going to be a probability. It is not about 0 or 1, right? So how do you know your model are predicted accurately? So here, I want to introducing about the threshold. So if you are interested in going to the data science field, so this threshold actually become a parameter you can adjust. So by default, we use 0.5 as a cutoff point because as you can think about the probability between 0 and 1, how about we pick the middle point? If the value is larger than middle point, that's make it equal to 1 because we believe that's going to be a span. If the probability less than 0.5, then we believe the probability for the span will be less than 0.5. We say, okay, if we toss the coin, 50% chance, but if it's less than 50% chance, that's going to be not a span, right? So therefore, we need to pick that threshold. By default, it's 0.5. So that's what we are doing. So once we got our predictions for that P, and then we do another level of the work, is if the value is larger or equal to 0.5, we label that as 1, means that's going to be a span, we predict it. If it's the probability is less than 0.5, we label that 0, means that's not a span. Okay, use the same example. So after we do that, and then we look at the number of, so we start comparing. So first, this is the first email is a span, and we predict it is 1. So then we match. So we accurately predict it. The second email is not a span, but we predict as span. So that considered as, okay, we didn't predict accurately. So it's inaccurate. So that's all we calculate called accuracy rate. So we no longer use this called R square. That what we did SSR divided by SSE, SSE divided by SST. So that's what we did before, SSE divided by SST. Now, instead, we are looking at the number of the correct prediction divided by the total number of observation times 100. That will give us accuracy rate. Again, so for accuracy rate, it's between 0 and 1, still like R square, right? Because your denominator is the total number of the observation you try to predict, and the numerator only focuses on the ones you predict accurately. So let's say you're predicting 200 data. Among 200 data, you have 20 are accurate. So 20 divided by 100, so your accuracy is 20%. Okay, so this is a new way to measure how good my data fit in the real world. This is literally for the binary. So again, if you are thinking going to the data science field, again, you need a lot of learning besides the undergrad level. I don't ever believe at this point, if you only get a bachelor degree, you call yourself data science, you most likely it's a data analyst. Okay, so if you are going to the hardcore data science route, you need to go further on your learning on the stats and the programming, especially stats. Okay, so once you go to the further education on machine learning, etc., we actually use accuracy rate a lot. Okay, accuracy rate a lot. So this is the model belonging to called a classification, because you can think about whether this is the span or not span, right? You try to classify your outcomes. So again, I will stop at here because I can talk more about this classification model because there are way more other models you can use. But this is the introductory class, allow you to think about another group of model you're going to see. So the way we measure this group is classification model. We focus on the accuracy rate. Okay, so let's look at the example together. Again, we are revisiting the spam email case, and again, focus on logistic regression column. Okay, so here, remember we have 500 samples, and then we are able to use the model we already predicted, already estimated, and then we plug in the value of the number recipient, the number hyperlink, the number of characteristics, and then we are able to use the logistic regression to predict. Okay, as you can see here, when we are using logistic regression model predicting this email, so the probability for that email being spam is 0.1266. So therefore, it's less than 0.5, so it will consider it as 0. So it's not, it will not be considered as spam. And if next email, the 17 recipient, 11 hyperlink, 68 characters. So since this probability is larger than 0.5, and then we will classify that as spam. So it's 1. So as you can see, the above 3 examples, they are 1, 1, 1. And then we compare this predicted value. Let me go back to the very beginning here. Okay, let me go back. Okay, here is where we see the example. You can see that for the first record, it actually not spam. The second is a spam. The last one is spam. So basically, this is the actual data. We compare with our predicted value. Let me go back here. So seems like the last one didn't predict it accurately, right? So the last one actually is a spam, but here predicting not spam. So now we look at every record among all 500 records to look at how many of them are predicted accurately. So we found out for the logistic regression model, we have 397 are correctly predicted. And again, we have 500 records, so therefore we use the 397 divided by 500. That is what we get. The accuracy for my logistic regression is 79.4%. So based on, we can use the same idea to calculate LPM. And so the accuracy is 78.80%. So therefore, our logistic regression model doing way better job than our linear probability model. Okay, so this is the introductory of logistic regression. Our key focus for this week's learning is, first of all, you make sure you know the differences between the linear probability model and the logistic regression model. Second, you are able to use both models to do prediction. Third is you need to know how to interpret the partial coefficient in the logistic regression model, which is how you convert the partial coefficient to the way so that you can interpret the value, how that impacting the odds, right? And the last one is how this accuracy read being calculated. Okay, so those are the 4 very important things hopefully you will know. So once you move on to the computer skill lectures, we are diving the actual example and use Excel to learn how to, first of all, to predicting the LPM, which we are able to use Excel. The second is giving the logistic regression model. Are you able to converting that to the coefficient that you are able to interpreting that the impact on the probability odds? And the last one is, are you able to calculate accuracy? Okay, so that's everything you need to know, hands-on practice. Hopefully this is going to be a very good introduction for you about logistic regression. Allow you to spend further time, like I said, either going to the real-world jobs or going to the master program to learn further about all those classification models. So logistic regression is a good foundation to start, and then you can move on to the further classification model. So the idea are all very similar. You just change different models. So good luck with your learning. Bye.